Thank you, sir. Thank you for the nice introduction. As all of you are aware that during the last month meeting of COP26, it is announced that India will meet 50% of its energy requirement with renewable energy up to 2030. So, in this regard, the sun availability in the country is very good. So, the photovoltaic activity becomes more precious for these activities. So regarding this, I am going to present Crystalline because Crystalline has the major share of world PV production. So I am going to talk on crystalline silicon solar cells and module fabrication, technologies, and cost. The presentation structure contains photovoltaics. All of you are aware about that. PV generation and technology status, share of different PV technologies, PV value chain, recent trends in crystalline PV manufacturing process, global and Indian PV manufacturing and installation shares, etc. The photovoltaics, all of you are aware about it is a direct conversion of sunlight into electricity. Becquerel discovered that effect. But the real birth of photovoltaic started from 1954 when three scientists from the Bell Laboratories discovered the PN junction-based solar cells with the efficiency of 6%. It is the first module and first solar cars. So the question comes, why photovoltaic is so important? All of you are aware that the no escalating fuel cost problem, no pollution. It is found that 1 gigawatt PV installation can reduce 3 lakh ton of carbon dioxide, no release of greenhouse gases, no waste or heat disposal problem, no noise problem, no transmission loss, because you can install the PV at site, highest efficiency of all renewable energy, and the most important is most rapidly decreasing cost. It is more than an annual rate of 10%. But use and implementation of PV sources is still low, although India is doing great efforts in this direction. All of you are aware about the solar cell operation. When the sunlight falls on a PN junction, electron hole pair generated, current flows. And so we are going for the next. The photovoltaic technology can be divided into 3 generations. The first generation, which we call the wafer-based technology, contains the single crystalline wafer-based technology, multi-crystalline wafer-based technology. The second generation, which we call the thin film semiconductors, contains the amorphous silicon, cadmium telluride, copper indium gallium disalunide based cells. The third generation, which we call the artificial photosynthesis and nanotechnology based generation, it contains the dye-sensitized organic polymer nanocrystal, and some new technologies are also emerging into this category. If we see the technology development status of different technologies, the wafer-based technologies are fully developed, mass production is going on. The thin film-based technologies are into the mass production, but the third generation-based technology, mainly dye-sensitized, they are mostly either the industrial research or the pilot plant scale. So, if you see the global annual PV technology share, you can see that the wafer-based technology contains more than 90% share, and thin film is around 7% or 6% right now. So question comes, why silicon? Because the availability of silicon is abundant. It is the second most available element on the earth crust, non-toxic, reliable and mature technologies for solar cell, potential for high efficiency. The PV value chain can be divided basically into the 3 chains. The first of all, sand is converted into the silicon wafers. There are different steps for that. Then the silicon wafers is converted into solar cells. And then the third chain contains the solar cells to module fabrication. And also some people are called the fourth chain, the installation of the solar modules. The first chain, if you're talking about sand to silicon wafer conversion, it contains the reduction of sand to metallurgical grade silicon, which is around 98% pure silicon. Then this metallurgical grade silicon is converted into photovoltaic grade polysilicon, which is 5N or 7N purity polysilicon. Then this PV grade polysilicon is converted into silicon ingots. Then ingots is sliced into the wafers. If you see the different steps, the silicon oxide is treated with carbon or coke at very high temperature. that makes the silicon into the form of liquid, and CO2 is evaporated. This reaction is carried out into a arc furnace, and that makes a 98% pure silicon. It contains different impurities levels. After that, this metallurgical grade silicon, which is 8% pure, is treated with HCl. That makes the trichlorosilane. And then this trichlorosilane is passed through a chemical vapor deposition chamber. And this process is known as the Siemens process. This is the most usable process for the fabrication of silicon, but it requires a lot of energy. The yield of the process is very low. It is around 45%, and high investment is required. So people are trying to replace the Siemens process into other different technologies. If we see the polysilicon manufacturing status, you can see that the top 10 companies share is more than 90%. So govern the silicon market, and Siemens process have a share more than 70 or 80%. So if people are new technologies such as FBR are also emerging, and it is expected because these are the low energy requirement technology. We hope that these technology will replace the Siemens process in the future. Then this polysilicon, which is 6N or 9N pure, then it is converted into silicon ingots. There are different technology. If you want to make it monocrystal, you have to go for either the FZ or CZ process. If you want to make multicrystalline silicon ingots, then directional solidification is the process is used by the industry. The quality of the wafer, it depends on the process, and it is generally measured in terms of lifetime of carriers. Generally in FZ, you can get 1000 microsecond lifetime materials, which is high purity, and generally the semiconductor industry use that wafers. However, the photovoltaic industry generally use the CZ or the multicrystalline wafer that is made by the directional solidification to keep the cost lower. These are different furnace provider, PV, Etapla, Ferrotech. These are different companies which is providing for the furnace for different ingot fabrications. A new technology is also emerging, which we call the quasi-mono technology. In that, the wafer is fabricated similar to the monocrystal because it contains the high lifetime, but the process is similar to the directional solidification. Then the silicon ingots is sliced into the wafers. There are different steps. First of all silicon ingot is sliced into bricks. Then bricks are sliced into the wafers. Nowadays, around 2 grams per watt peak silicon is consumed in the wafers. And if we're talking about the recent development, recently the multi-wire technology for more throughput of the wafers is developed. People are using the diamond wires in place of SS wires for the reduction of the curve losses, and less wire thickness wafer are used to reduce the curve losses. Then the next step, these are the technology provider for that: Meyer Burger, Applied Materials, Themis. These are the industry which are providing the tools for the silicon wafer manufacturing. If you can, by the naked eye, you can identify either the wafer is monocrystalline or multicrystalline, because generally in monocrystal it is quasi-mono. You can from the corner you can identify. In multicrystalline it is mostly square, but nowadays people are trying to make the monocrystal in the form of a square also, and efforts are going on to increase the size of the wafers so that the maximum light can be absorbed and the maximum current can be gaps into the solar cells. You can see that the 156.75 size, which is generally called is nowadays disappearing, and the 158, 166, 182 size wafers are coming into the market. The wafer thickness is also reducing. Nowadays, around less than 100 micrometer wafers are used by the PV industries. The next chain is conversion of these wafers into the solar cell production. There are different steps. First of all, P-type wafers is used by the industry, having the resistivity of 0.5 to 3 ohm. Then these wafers are textured into the alkaline. If you are using the monocrystal, you have to go for the alkaline texturization. If you are using the multicrystalline wafer, you have to go for the acidic texturization. Then the diffusion is basically the PN junction for fabrication, as isolation, anti-reflection coating into the front side. It is a blue color layer. All of you have seen that. It is basically the silicon nitride coating into the front side. Then the front contact printing, back contact printing, and the testing of. We will discuss each and every step in the next slides. This is the structure of the solar cells, and this is a typical industrial process for the solar cell fabrication. You can see wafer inspection, chemical polishing, diffusion, edge isolation, phosphorus glass removal, anti-reflection coating putting, then the metal printing on the front and back side, and the co-firing, and then the testing. If you see the texturization, this process is used to convert surface of the cell with the micrometer size pyramids. It is around 5 micrometer size pyramid is fabricated on the surface to reduce the reflection losses. In mono alkaline texturization, using the NaH or KH with IPA solution is used. However, for the multicrystalline acidic texturization, using HF, HNO3 and H2SO4 solution is used. Nowadays, dry etching techniques is also emerging, such as reactive ion etching, which is and the tools are coming for that technology. So to reduce the consumption of these alkaline and acidic solutions, and to reduce the cost of the fabrication process. The next step is the diffusion. The diffusion means making the PN junction. In the generally the POCl3 tubes spray diffusion is used. There are lots of companies such as Centrotherm, Tempress. These are providing the furnace for making the PN junctions. Some industry, if you go, you will find that they are using the phosphorus paste, and then such as Centrotherm, Meyer Burger. They means if you go with different tech industries, you can find the different process of diffusion. And some companies are also trying to develop the tools for using the ion implantation, such as Varian and MTech in USA. They are providing the tools for that. That will reduce the process step, as well as making the shallow junctions in the solar cell fabrication process. Then a anti-reflection coating is used into the front side. It is generally used by the silane and ammonia gas mixtures into a PECVD reactor. And Rothenrow, Meyer Burger, Centrotherm, these are some technology provider for the PECVD furnace. Some Olicon, although it is closed now, they are the sputtering tool for this PECVD and anti-reflection coating manufacturing. The next step is metallization. In the front side, generally the silver metal is used for making the contact. Into the back side of the solar cell, there are two types of printing. First of all, a silver aluminum pad is printed, and then in the back surface, it is full covered by the aluminum metal, using the screen printing technologies. These are DuPont's, Ferro. These are the industries which are providing the metal paste, and Applied DEC. These are the companies which are providing the metallization printer for the solar cells. In recently, some new technologies are also coming into the market for the reduction of the silver consumption, such as a dual print, that is increasing the aspect ratio, so you can get the higher current print on print, and the throughputs of these metallization printer is also increasing. Nowadays you can find 3,600 self printing equipment easily into the market. Then all the metals are co-fired together to reduce the energy consumption. And if you can see, you can find that if you go 5 or 6 years before, you can find there are cells which have contains only 2 bus bar, 3 bus bar. But nowadays you cannot find any industry which is making bus bar or 3 bus bar. Nowadays industry is moving for the 5 bus bar and 6 bus bar cells to reduce their losses. And it is expected that in the future you can also find the bus bar less or 6 bus bar or 10 bus bar cells into the market. The next step is testing of these cells. Standard test condition is air mass 1.5 spectrum irradiance 1000 square at a temperature 25 degrees C. In this, all the ISC, VOC, fill factor is test for each and every cells. Nowadays, there are 2 different types of testers are available into the market. You can find the LED-based tester in place of conventional xenon light-based tester, because in the LED-based tester you can replace a particular LED if there is any problem in the irradiance of LED. So it reduces the cost of the amp. It is the best research cell efficiency for different cells. I think all of you are aware about the efficiency of all the cell technology. Next step is conversion of silicon solar cell into the module production. In this process, cells are connected together in series and encapsulated into a module. Modules can be used singly or connected in parallel and series for making the array. PV array integrated in system with components for charge regulation and storage. Of systems generally on-grid and off-grid PV systems are making as per their use for rural or urban applications. Generally, if you see, there is a standard for making the solar modules. If you go into the Indian industry, they are making the module either using the 36 cells or multiple of that, because our concept is basically depends on the batteries. Generally, for a single battery system, 36 cells is used. However, for a dual battery system, when the nominal voltage is required 24 volts, a module of 72 cells is used. However, if for the other countries, their standard is 60 cells. Nowadays, people are also making the module with the 96 or 80 cells modules are also available. But that makes the modules quite big, and it is difficult to install these bigger modules. And there is always a possibility of cracks, etc., in the cells or the glass. If you see the overall picture of PV modules, it contains a glass, then EVA layer into the front and back side, and a back sheet. Generally, we call it Tedlar, and it is encapsulated into a single piece. These are the different process steps for the module manufacturing. First of all, the glass washing is used. Then tabbing. Tabbing means interconnection of cells into the series layer. Then layup means putting the EVA layer into the front and back side. Then these are the bus bar cutting machine. Then busing, putting interconnection of these strings which you are making through tabbing. Then a barcode and RFID tag is also fixed inside the module. Then visual inspection, electroluminescence inspection to finding the cracks, etc. Then the lamination is going on. Then framing, generally a aluminum frame is put to protect the corner. Then junction box putting and IV testing of the each and every module. This is a typical diagram picture of process. If you're talking about the solar glass, the cleaning is used to remove for the oil and dust particles. In India, generally the Gujarat Phil and Allied glasses, they are making the solar glass. The glass contains the low iron content glass. It is tempered glass, has the transmittance more than 90%. If you see the recent achievements into this glass, nowadays people are using the anti-reflection coating glass, which contains the transmissions more than 94%. Thickness of the glass is also reduced to reduce the cost. Nowadays, 2.4 mm glass is used by the PV industry for these bigger size modules. The glass is free from antimony and arsenic because it is found that after completing the life of the module, generally people put these modules into the field, and that contains the arsenic, and that is going into the earth or the water. So people are nowadays using the arsenic-free glasses for the colored glasses is also available for making beautiful modules. The tabbing and stinging in this process, PV ribbon of width 1.2 mm is used, copper material is used, that is contains different industries using different ribbons, either SNPB or some lead-free ribbons are also available. Comex, Solar, Eco-Pragati, these are the tabber and stinger manufacturer, NPC Japan, etc. These are providing the full automated line for the module also. So recent achievements is lead-free ribbons are available, silver-free ribbons are available to reduce the cost. Tabber throughput machines high throughput tabber machines are also available. You can find 3,000 cells per hour tabber machine into the market. The next step is busing. If you go globally, this is generally doing on the manual basis. It is process of interconnection of these strings together. And here a PV ribbon of 5 mm is used. Ribbon material again the copper, and it is basically the solder coated ribbon is used. If we're talking about the new development for the PV ribbons, you can find the textured ribbons also into the market. That also, it is saying that they also help to reduce the reflection losses, but the cost is slightly higher. So PV industry right now is not using this textured ribbon for the manufacturing. The next step is layup. In this process, solar cell string are put in between various layers for lamination. It is basically the ethyl vinyl acetate film that is used. Nowadays, high transmission type of front material EVA layers are available. UV cutoff type of backsheet is used. White and textured EVA sheets are available. Anti-snail trails protected EVA layers materials are also available into the market. The next step is electroluminescence inspection of any cracks, etc. into the module, because after lamination you cannot remove any cracked cell from your module. So before lamination you have to check each and every cell. If there is any crack, you can remove that particular cell from the strings, and after that, the next step is for the lamination. It is the putting backsheet. There are different type of backsheet are also available to reduce the cost. If you see initially TPT layer is used, but nowadays KPK, TPE, KPE, different materials are available. That makes the module more cheaper. But the life of these backsheet is also important. You can find if you are not using the good type of backsheet, you can find that the module become yellowish. Sometimes it is find that the broken backsheets from after 4 or 5 years. So the backsheet selection is also important part of the module fabrication process. Then the lamination process. After that, all the multi-layers is put it together. This process is taking place at around 150 degrees C for 15 minutes. And there are different backsheet manufacturer, EV manufacturer, Bridgestone, laminator manufacturer are available. throughput increases, double stage and multi-operating laminators are available into the market. Single laminator is capable to tackle around 250 megawatt capacity. Oil-based heating laminator is also emerging due to less electricity consumption comparison to coil heating-based laminators. But in China, we have had some accident also using these oil-based heating laminators. So in India, mostly people are using the coil heating-based laminators. Then the next step is framing. Framing is putting the aluminum frame onto the module. Nowadays, aluminum frame is used, but in the future, people are talking about the frameless modules, either plastic frames or without frames modules may be available for reduction of the cost. The next step is putting the junction box into the backside of the modules. Nowadays, people are using the neutral adhesive because the selection of this adhesive is also important for the longer life of the modules. So people are talking about less curing time. Generally, for the curing of these adhesive, it takes around 8 to 10 hours. So some adhesive which takes around 1 or 2 hours is also available. And people are, but the lifetime of these adhesive is also important. Then the next step is module testing. Module is tested as per standard conditions. There are different companies such as Bush Solar, Halm. They are providing the sun simulator for testing of the modules. And LED-based tester, module tester is also emerging in place of conventional genol-based testers. If you're talking about the new things, half cell cut modules are also emerging in place of full cell modules so that the higher efficiency can be get from the single modules. Bifacial module, flexible and bendable module for the curved structure is also coming into the market. If you see the Indian PV manufacturing, we have around 10 gigawatt module production capacity, and the solar cell capacity is around 3 gigawatt. But in the country, we don't have the wafer and ingot manufacturing right now. Some people previously announced, Reliance and other companies have announced that they are going for the wafer manufacturing or ingot manufacturing, but right now nobody is making. We hope that in future wafer and manufacturing will be carried out into the country also. If we see that the global installation, we have installed around 45 gigawatt PV, and the government has a target to install 100 gigawatt up to 2022 under national mission. And recently it is announced that the capacity will be reached around 500 gigawatt up to 2030. If we see the module price, it is reducing nowadays around $0.2 per week or lesser than that modules are available. So thank you from my side. Thank you very much.